Afternoon, hope you're all well. We're going to be looking at exercise 6C. So this will be the last one for this term. So when we start now next term, you need to make sure you're all up to date because we'll be starting the next section, which will inevitably be 6D. So factorising of polynomials. So we're going to start off with the remainder theorem. So if you've done, and you should have done loads and loads and loads of these from the previous exercise, you'll know that if you divide x squared plus 5x plus 12 by x minus 2, you have to do loads and loads and loads and loads of work, and you end up with a remainder of 25. Lot tricky, so the remainder theorem is a shortcut method for us to do that. So if we sub 2 into the polynomial, just p for polynomial, we get x cubed, 2 cubed, 3x squared, 3 times 2 squared, 2x, 2 times 2, and of course the 1 stays the same. 2 cubed, 8, 3 times 2 squared is 4, 3 times 4 is 12, 2 times 2 is 4, plus 1, 8 plus 12 is 20, plus 4 plus 1, 25. Same answer. So we're happy. Question is, why do we sub in 2 rather than minus 2? So hopefully you're all answering this question now. Reason being, we've got an x minus 2 there. So we know that that will cross the x-axis at the point plus 2. So we just change that sign. So a couple of questions. So we're going to do a bit of board work. So this is what you need to write down. So I've had a go at trying to do board work without obviously us having the board here. Let's see if it works. So we're going to have to sub in, because we've got an x minus 2. We're just going to have to work out what p of 2 is. So p of 2 is going to be 2 cubed minus 3 times 2 squared plus 2 times 2 plus 6. 3 squared is 8. 3 times 2 squared, 4. 4 times 3 is 12. 2 times 2 is 4 plus 6. And that comes out to be 6. So we'll use the remainder theorem to find the value when. So the value is 6. Second one. So here I have to sub in minus a half. Change that sign. Like I did there, I changed that sign. Now what I did here was I actually did 2 divided by 1. 2 divided by 1 is 2. So whenever you've got a monic, so when you've got a 1 there, you never really do the division. You just say, okay, I'm just going to change that to a plus. I'm just going to sub in 2. So here we've got a 2 in front of it. So we change that to a minus, and that 1 is divided by 2. So I've got 1 divided by 2 gives us a half. So I've got minus a half cubed, minus 2 times minus a half, plus 4. So that's minus 1/8, because a half times a half times a half is an eighth, and a minus is a plus. Because we're doing it again, a plus and a minus makes a minus. It goes back to being a minus again. So 2 times a half is 1, minus and a minus make a plus, plus 4. So now I've got to change all these to eighths. So 1 plus 4 is 5. 5 eighths are 40. So that's 40 eighths. So if I've got minus 1 plus 40, I've got 39 eighths. That's how we work that one out. Factor theorem. So the factor theorem is very much like the remainder theorem. It's when we get a remainder of 0. Go back to primary school. When you do division, you always get a remainder of 0, don't you? 5 divided by 2, sorry, 10 divided by 2 is 5. 15 divided by 5 is 3. You always get a remainder of 0. Okay, so what we're going to look at now is when we get, when we use the remainder theorem, we'll call it the factor theorem now, so we get a remainder of 0. And here is, on a cave, the first known recording of a 0. The Romans couldn't do it. Show that x plus 1 is a factor of that, and hence find the other linear factors. So lots of the questions that you're going to be doing in this book, in this exercise chapter 6, and also for the rest of the year and next year, if you're doing methods next year, will be this kind of thing. It's quite a long process. So the first thing we've got to do, can I have a go doing some board work again? The first thing we do is we've got to sub in minus 1, haven't we? So minus 1, because we've got a plus 1 there. And we're hoping that we get a remainder of 0, because it's telling us to show that it's a factor. If it's a factor, it means we get a remainder of 0. So minus 1 cubed, 4 times minus 1 squared, plus minus 1, plus 6. So that's a minus 1, because a minus and a minus and a minus carries a minus. That becomes a plus. So minus 4 times plus 1, minus 4. That becomes a minus. So we do get a 0. So I'm happy. I've got a 0. So first step. Now what I have to do is I have to actually do the long division to find what the other factors are. So even though I've proven that it's a factor, I've still got to do the long division. As you can see, I've done the long division here. Here is my thumb when I took the photo. So I did the long division. If you're still not sure how to do it, work through that carefully, or make sure you've done the previous exercise. So what it's telling me is that when I do the long division, I get that solution, the answer. So I can factorize that now. So I can put that into 2 brackets. So now I've actually factorized it fully. I've got this bracket here. So I've got this one here, x plus 1, x minus 2, and x minus 3. So that is now fully factorized. I've found all the linear factors. So I've proven that that is a factor, and then I've found the other linear factors. Now, if we just draw a graph of that, so I've just used my graphics calculator to draw the graph, we can see that it crosses at minus 1. So that's that one. It crosses at minus 1 from that one, yeah? Here it crosses at 2. So that's that one there. There it crosses at 3. That's that one there. So we've done all the maths, and our graph is showing us that we're correct. Now, in your graphics calculator, you can actually create a table. So if you go to table, you can have a split screen table. So you can find this bit on your calculator, click on that, and you actually end up with a table of all the values. So what's this telling us? When x is minus 1, the value is 0. So when x is minus 1, it crosses the x-axis. Here at 2 and at 3. And I can scroll up and down with this one. Telling me when x is 0, it crosses at 6. And I know that from the original equation, don't I? So originally I knew that it would cross at 6. And if I could scroll up and down, it would give me all the values. It would give me all the x values and all the y values. Now, as you can see here, I've just got whole numbers, so I can change it. If I wanted to, it went up by half, so it could go 0, a half, 1, 1.5, 2, 2.5, 3. So have a play around with that. You've got plenty of time to do that, haven't you? Okay, factorize these. So just come up with a pause button. So when you see a pause button, that's when you have to pause this video and have a go at doing those two. So fully factorize those. So pause it now. Okay, you've unpaused it now. So let's have a look at this. Some special cases. So these are just 2 formulas that you kind of got to remember. Obviously, if it's the tech enabled, you can have your notes, but if it's the tech 3, you're not going to have your notes. So this is the difference of cubes. This is the addition of cubes. Well, we've got the negative, we've got a negative there, we've got the positive, we've got a positive there. We've got a negative there, they're all positive. We've got a positive there, the first one's negative, the second one's positive. So you've got to remember that somehow. Let's have a look at some examples. So it's more board work. So the first one, if we just write it as 2 cubed. So 27 is 3 cubed. Kind of got to know these things. Now we know that a is 3. So once we've put that into them to both into cubes, we can see that a is 3. So now basically I'm just going to use this formula and substitute in a for 3. So it's x minus 3, x squared plus 3x, 3 squared is 9. Easy. This one here, that's not a cube. It's a square, isn't it? 8 times 8 is 64, but there's no way we can work that out to be a cube. So, but look, 8 goes into that, 8 goes into that. Let's do a simple, just take the x outside first. Now, 8 is 2 cubed, isn't it? So 2 cubed. So now I can just rewrite that one as x cubed minus 2 cubed. And now I know that a is 2. So now I just rewrite this one with a being 2. Don't forget the 8. So go plus 2, x squared minus 2x plus 2 squared is 4. Then that one there, pretty obvious. That one there, they've done a one little sneaky thing. You might find that when you do the exercise, they try and be a little bit more sneaky. So use your problem solving skills. See if you can work that out. Here's all the section summaries. So some notes for you. There's some work. Have some lovely holidays. Make sure you do lots and lots and lots of work. And I will be in contact with you next term. But if you've got anything, just go straight to Google Classroom, start typing in questions, anything like that. Send me emails. Happy to hear from you over the holidays if you get stuck. Over and out.